also is from Dell, and his name is Mr. David Park, and he'll be talking about, I like this title, zeroing in on the 0 day. So, David, go ahead.
Sure, thank you. Thanks, everybody. It's great to be in an academic environment again. I spent a few too many years in academia where my presentations consisted mainly of Greek symbols. Over the years, my brain cells have slowly died, and so my presentations these days consist mainly of very few words in English and lots of pictures. So I'll try to keep this kind of to the point and brief. So I wanted to talk about kind of the top 5 reasons why machine learning is changing the game in the fight against malware, right? So machine learning can mean a lot of different things to different people, but one thing that we do know is that it's now pervasive, right? In the cars that we drive, or we might be driving pretty soon, to your appliances. So why not apply machine learning to fight kind of the ever-growing problem of malware and viruses? So reason number 1, why is machine learning so critical? Well, these days, attacks typically involve mutations. So you can even take a off-the-shelf virus or some malware that the world already knows about, and you can run it through free services. You don't even have to be an expert hacker. And what it does is it basically flips a few bits here and there, or it might pack it with some bits. And the end result is now an executable that's no longer going to hash or index to a known signature anymore. And no wonder why so many organizations, especially here in California, Presbyterian Hospital earlier this year, it seems like every month or every week there's some new organization or hospital or university getting hit with ransomware when they already have traditional antivirus products and all these different security products already in place. Like, why are they still getting hit with CryptoLocker or different types of ransomware? And one of the main reasons why is that now the majority of attacks involve some sort of mutation to a known virus or an off-the-shelf virus, or it's a true 0-day attack, right? Something that the world has never seen before. And unfortunately, the old way of doing things, which is constantly keeping signature databases up to date and trying to figure out, what everybody else has seen before, just isn't keeping up, right? Because it has to be seen before. But unfortunately, a lot of the attacks these days, it just takes a simple mutation or a little bit of bit packing to mask it from signature-based antivirus products. So second reason, machine learning, fortunately, is not so easy to fool, right? So bit packing or mutating off-the-shelf viruses that might mask it from conventional antivirus products. It's a little more difficult when you've got some deeper intelligence, namely using machine learning to really understand the DNA of the attack, the DNA of the executable. And so through a technology partnership that we have with a company called Cylance, Dell Cylance has come out with a product, a technology, that applies machine learning to analyze millions of different artifacts, characteristics, and factors in an executable, and trains it to be very, very smart at understanding what factors, what correlations of factors in that executable might cause it to be malicious. And so over the years, we ran it through, I think, close to 800 million actual malware, trained this machine learning model over hundreds of millions of actual malware as well as benign executables, right? So you want this to stop malicious executables, but at the same time, you want it to let through or allow the good programs to run. And the beautiful thing about machine learning is that you don't have to come up with a heuristic yourself. You don't have to, figure out or code exactly what it needs to look at. The beautiful thing about machine learning is that the more that it's trained over actual samples, right, real samples, it automatically starts to converge on kind of an optimal set of factors, weights, and correlations, right, in what it analyzes, to be able to become very efficient and very intelligent in predicting whether a new executable that it sees is malicious or not. And the results are pretty astounding. So we actually did a live lab result kind of bake-off, right? So it spanned about 75 different cities, and in each place we ran kind of a side-by-side comparison of how the machine learning-based anti-malware solution performed and compared to the three currently leading antivirus products by market share, right, which are Symantec, Trend Micro, and McAfee. And they took the same malware, same viruses, Trojan horses, ransomware, about 15,000 of them. Many of them actually were stuff that they pulled live, right? So things that people were seeing that day. They even took a subset of them and mutated them, which again is kind of the normal practice these days. And they threw it at Dell Silence, and they threw the same attacks at Symantec, Trend Micro, and McAfee. And across the 75 different bake-off live lab results, Dell Silence stopped and quarantined 99.8% of the malicious attacks, whereas the other products came in somewhere between 20% to roughly half. And unfortunately, the gap is growing, right? The more sophisticated the attackers are becoming, the more that viruses and malware are getting mutated. This gap is only going to grow. So reason number 4, why machine learning is changing the game in fighting malware. So this is another problem that we see, and I work with very, very large enterprises, and one of the most challenging issues that they're dealing with is everybody knows security is important, everybody needs security, but they think that in order to have security, it has to come at a cost of operational efficiency, or a cost to performance, or making a lot of people's lives miserable. And unfortunately, a lot of security products are like that, right? They slow down machines, it's constantly running scans on your laptop, and you're trying to watch a movie or play a game, and you can't anymore because it's eating up system resources. At the same time, especially with the enterprises that I deal with, like they have teams of people whose sole job in IT is worry about keeping signature database updated all the time. And it's eating up network bandwidth. It's taking a lot of manual effort, just constantly making sure that signatures are updated, trying to keep up, right, with attacks. And the beautiful thing about machine learning is that all of the hard work was done up front, right? Years of training over hundreds of millions of actual viruses and malware, where now it's really culminated down to a very, very simple, lightweight, fast agent. And all it does is it codifies the machine learning, right, analysis down to just a series of floating point operations. So rather than having an AV product that's just scanning and scanning and scanning and updating. Now you've got a solution that can analyze and quarantine malicious executables in a matter of milliseconds. And in practice, what we found so far with our customers is that's one of the first things that they notice is they say their end users, their employees, are realizing their machines are running a lot faster. They've gotten that performance back because they're not relying on constant scans or relying on detecting viruses by relying only on signatures. And lastly, what we found also is security products aren't very effective if it's not in use. And you know how many times I've gone into organizations where they've spent millions of dollars on security products, but it's sitting on a shelf, or they've only deployed it to a subset of their environment because it's causing too much of an impact on performance or their IT operations. And unfortunately, that's just how the world is they realize, if it's going to impact my end users or my business processes, I can't afford to push out security. And so the fact that our solution provides a very transparent end user experience makes it easier to scale and to push out to everybody in the organization so that you don't have to make that trade-off, right? Do I want more security or do I want more operational efficiency? With machine learning-based anti-malware, you actually get both, right? You get a high rate of efficacy, right? Being able to detect 99% plus malicious attacks, but at the same time, it's not going to impact your performance in a big way. And secondly, it's not going to pop up or cause any disruptions or change the way users work on their machines. And then reason number 5, one of the benefits of machine learning-based anti-malware is that it actually analyzes executables or attacks statically. What that means is it actually can detect and quarantine and stop malware even before it detonates. And there's really 2 main benefits to this approach. One is a lot of attacks these days, as soon as it detonates, it actually doesn't really do much. So if you remember some years ago, the big attack with Sony Pictures, the way it started was actually an endpoint attack. I think it was a mutated version of some known attack that just went past their AV. And ironically, it was a couple of guys in IT admins that decided, I'm going to download this and click on it and let it execute because it's this like cool little screensaver. And it didn't do anything else. It didn't blow up anything. It didn't, cause data to get suddenly encrypted. But all it did behind the scenes, as soon as they double-clicked on it, was it inserted a little backdoor, a little Trojan horse, and that's it. And for months, it did not do anything. And only months later, when their guard was down, they actually used that little backdoor to push out an executable through their SCCM and give them access to all of their back-end resources, right, including all of their emails. And if you remember, this was big in the news. I think the Sony's president's email got put on WikiLeaks, and there were a lot of disparaging remarks that she made about President Obama and so on. Actually, personally, I got impacted too, because I actually had correspondences and some attachments that I sent over to Sony Pictures, and even that ended up on WikiLeaks. So today, when I do a Google search of my name and my cell phone number, it actually, one of the first things that pops up is an attachment that I sent. It was a quote that had my name and my personal cell phone number on there, and it actually pops up as number 1 on Google. So it's pretty bad what happened. But what that did was it detonated and it just placed that back door. And a lot of times, new companies these days or new technologies, they focus on how do we analyze malicious attacks as they play out to be able to stop it and try to eliminate it, right? Erase it, get it off the systems. But unfortunately, the damage might already have been done, right? In the case of Sony, all it did was place a back door, right? Even if they had some of the smartest people in the world or some of the smartest technologies trying to analyze, behavior to see what's happening, it probably would not have worked because it didn't really do anything, right, when it first detonated. So the beautiful thing about static analysis or machine learning-based static analysis is that the attack never gets a chance to even run. So whatever backdoors or Trojan horses it might try to insert, it's not going to happen because it never executes on the endpoints. The other benefit to this approach too is if you look at this graph, sometimes it kind of gives me a headache trying to figure out what it is, but the later that you can respond or react to it, right, the risk goes up. Case in point, Sony, right? The later that you can actually see that there's something bad going on, it might already have done its damage, right? Backdoors, Trojan horses. But at the same time, the cost to deal with the attack also grows exponentially. If you can predict, if you can use automated analysis, right? In our case, we leverage machine learning to automatically detect and stop malware by preventing it or predicting it even before it runs. It's a lot less costly to deal with than if the attack has already played out, and now you've got to engage semi-automated or even manual labor, right? Even if you have some of the smartest people in the world, unfortunately, it costs a lot of money, right? And time and resources to try to eliminate the effects of that attack playing out. And so more and more we believe that the solutions that are going to scale and the solutions that are going to keep up with the type of attacks that we're seeing has to be more automated. And at the same time, we have to be able to catch it early. And ideally, the best time to catch a threat is before it actually executed, right, or it detonated. That's really where Delph Silence comes in, is instead of relying on signatures and constantly trying to play catch up or whack-a-mole, right, which organizations are dealing with, we really believe that a new approach, and in our case, using machine learning to proactively analyze and quarantine malicious executables before they run, but at the same time making sure that we're not impacting the end users, we're not eating up system resources or causing disruptions to ordinary business processes, will really give organizations a security technology that they will want to deploy and can deploy to their enterprise. So as I promised, nice pictures, kept it pretty brief. I'll open up to a discussion or any questions you'd like to pose. Sure.
So I had a question about applying machine learning to programmable logic controllers or low processor intensity things, looking at comparing firmware hashes and organizational pushes on kind of embedded, low horsepower embedded systems.
In the context of security or just in general machine learning?
Basically, in the context of basically an attacker changing from making a firmware change or very small firmware change in a control algorithm, and your ability of the application of machine learning to that kind of problem.
Yeah, great question. So those are some of the things that, as I mentioned in one of my earlier slides, there's millions of things that we look at in an executable. And one of the things that kind of throws up a red alert, I think, to the machine learning algorithm is if it starts doing funny things like changes to the firmware or changes to the registry or trying to mask itself from the OS, trying to hide itself or doing something weird, right? So to speak. And the power of machine learning is that each of those things individually might not constitute enough of an evidence to say it's malicious, but it's the combination of those things and the correlation of those different potential activities that the executable might run that will give it a score high enough to say, hey, this looks suspicious, let's quarantine it, right? And trying to find all those correlations and what factors or characteristics about an executable might constitute malicious behavior versus non really is something that the machine learning training automates, right? It actually looks at a lot of different types of attacks, millions of other types of attacks that people have gotten hit with. And if there's patterns or correlations that it sees similar to these attacks that people have gotten hit with, it'll basically give it a high score and then quarantine it as a malicious executable. But you hit on a good point. Some of those things we can actually analyze the executable and say, hey, it's trying to call up to a control and command center, or it's trying to, change some stuff in the firmware or the registry. Those are things that we definitely key in on.
You said this is a thin client. Is this just for PCs or is it for any IoT?
Yeah.
The controllers for the read or?
Yeah, right now it's for PCs and Macs and servers. We have Linux support coming up very shortly. There's studies out saying that some 70% plus attacks these days target the endpoint, because the endpoint tends to be the weakest link, right? In Sony's case, it was a couple of IT guys that thought it would be funny just to, click on that little executable to have that funny screensaver. And because of that, even though the solution doesn't solve everything, right, there's no silver bullet out there. There's nothing that will do, give you all the security you need or give you 100% efficacy rate. But we really believe that the first place you should start is with the endpoints, because that tends to be the weakest link. And if we can stop and quarantine 99% of these malicious attacks, that's a great start, right, to anybody's security initiative.
My company right now is using McAfee
Okay.
for the malware antivirus thing on all the users' Windows desktop. This machine learning, and one of our biggest threats right now is end user receiving an email with a spear phishing link,
Yeah.
and they accidentally click on it. Can this machine learning prevent, even if when a user click on the link, it prevent the malware from
Yes.
installing on the machine and spreading out?
Yes, it does. And it even deals with fileless attacks as well, so in-memory attacks. It's able to analyze it and apply that machine learning model to that as well. So it's not just relegated to some attachment that you might get in an email.
How does it actually work? So we have to install an agent on each Windows desktop, is how it works?
Correct, yeah. There's a little agent that you push out. It's actually pretty small, that you push out through SCCM or Case or Alteris or whatever you do to push out software. And that installation process is silent, right? So the end user doesn't see anything. They don't have to bring their machines in. And even when it's doing its machine learning and analysis and quarantining, you can set it up so that the end user doesn't see anything, right? It's not going to pop up and say, oh, we quarantined some virus. And generally, I've been in the security space for a long time. What I found is the less the user sees, the more secure you are.
So, I was just wondering, is machine learning, can it be as effective with non-malware like DOS attacks or something like that?
Non-malware DOS attacks. Like, could you give me an example?
I mean like just like a DOS or a DDoS attack specifically. Is it as effective with those?
Yeah, well, it depends on the type of attack. DOS attacks can come in many forms. In my prior life, I actually started a company that attacked this problem from the other side, which is a lot of security problems or security exploits, right, DOS attacks especially, they actually originate because of bugs in the software or poor coding or poor coding practices. And a lot of times a DOS attack could be somebody understanding how to trigger a bug, right? Because if they can get it to trigger and get it to a place in the code where it starts let's say referencing a null pointer, it's going to crash. And if the software crashes, there you go, denial of service. It's not going to run anymore. And so, with my previous company, what we did was we applied static analysis, just like here, in analyzing software automatically to pinpoint those security holes, whether they're buffer overruns or whether they're string overflows and things like that. And attacking the problem from the inside out is if you can, eliminate more of these defects in the code or security flaws, then you're really kind of dealing with the problem from the source, right? The root cause. Unfortunately, there's actually computer science theorems that say you can't find and fix all bugs in software. So I really believe, whether it's denial of service attacks or other types of attacks, that it really takes a combination of both, right? You need technologies that can help you, right, build better code or have applications that are less buggy, if you will, or with less security holes. But at the same time, you have to have new approaches to putting up defenses, whether they're automated tools, targeting the endpoint, or whether they're like Dell SecureWorks that apply, some of the smartest people in the world to help organizations recover, especially if there's an attack playing out.
What is the cost?
Cost? How much money you got? Sorry?
It's dependent on budget. So let's say I have a small company, 10 people, am I able to use your product, or is that more for an enterprise?
Yeah, you can use it in kind of a small environment, or maybe like 10 or 20% organization. But typically, we target the enterprise. So think, our typical customers range from anywhere from 200 to 80,000 endpoints. But in terms of cost, it depends on volume. The nice thing about the Dell Silence solution is that if you happen to buy Dell machines, now this will work on anything, right? Macs, it'll work on HPs and Lenovo's, but if you happen to be buying Dell machines, you can actually buy it together as a system, right? Part of the machine that you buy at a fraction of the cost that people would typically pay for solutions like this. So, Dell, one of the reasons why Dell invested billions of dollars in acquiring and partnering with leading edge technologies like this is we really believe that the more that we can bundle and integrate some of the leading security technologies on the box with the hardware, and the tighter that integration is, the better it is for the end users. It'll run better, faster, and also it'll result in less security holes that attackers can exploit. And so it's kind of the big vision that Dell has is, hardware and software, they should really work hand in hand, especially with security software. And the tighter that coupling is, the less vulnerable you are to attacks.
Another question, who houses the server? Is that part of?
Great question. So we have two versions. One is a cloud managed, right? So if you don't want to set up anything on premise, there's a cloud managed version of this. The larger enterprises, they want to keep everything in-house, right? They don't want any, information about potential attacks outside of their four walls. And so the other version that we have, it's an on-premise management server, kind of a web-based console. And all of the information around executables and attacks that is quarantined, they all stay within an encrypted SQL database on premise in your organization.
Excellent, thank you.
So a quick remark I wanted to make, and I observe this quite a lot. Machine learning is becoming a more and more popular technique in cybersecurity. But there is one trend I frequently see in research is that a lot of machine learning experts, they're approaching a security problem as a machine learning problem. Just as an example, they would design an algorithm which you can train, for example, to recognize a particular kind of threat. And you can run it through diverse kind of data, and it seems to give pretty good performance, good classification as they call it. But a point which many of those people miss is that there's going to be people out there who will be specifically trying to deceive that system, to trying to interact with the system in a way in which it was not trained to recognize threats. I see that trend quite a lot. So what does Dell do in order to avoid this kind of mindset? Because I think it's very easily fallen into in machine learning research.
Right. No, that's a really good question. So I'll answer it kind of in a two-pronged way. First, hackers are always trying to figure out how do I step one step ahead, right? How do I outsmart whatever new defenses or new products or new technologies are coming out? And what I'll say is, compared to, there's really a spectrum, right? So most organizations are using signature-based AV, and those are really easy to bypass or subvert because it relies on direct matches, right? So they have a database of signatures, and like I said, all it takes is somebody can take an off-the-shelf virus that people know about, they mutate it, flip a few bits, and now they've basically subverted or worked around the signature-based approach. On the other end of the spectrum, the beautiful thing about machine learning is that it's not just based on a handful of heuristics that somebody picked, thinking that those were the best heuristics, right? The thing about machine learning is, first of all, it's continuous. It's constantly being trained over, new attacks coming out today, and so it's able to really codify a bunch of different correlations and heuristics that a human being might have a tough time, right, coding or codifying. So it's a lot more difficult to try to work around. But that said, there is no foolproof way. Like even with machine learning, somebody smart enough can say, hey, I think that it's really assigning more priority or weights to looking at these characteristics of the attack or the executable. And let's say they come out with a new attack that happens to bypass this machine learning. Well, if that happens, what we can do is we can take the hash or that, the things that, the machine learning computed for that attack and basically create new logic within a period of about hours or within less than a day. And it's called a centroid. So we can release a centroid to a customer if they've been hit with a new type of attack that, let's say, our machine learning algorithm wasn't, most suitable to detecting. And now that new logic can detect not only that type of virus, but other mutations or variants of that. So that's really where the machine learning power comes in, is a lot of times when organizations get hit, other organizations, or that same organization, there's a high likelihood they will get hit again with some variant of whatever that original attack was. And the beautiful thing about machine learning is, hey, we can train and create new logic to account for that new type of attack, but at the same time, that new logic will be able to help stop a lot of the different variants of that new attack as well.
And one more thing I wanted to add to that, I guess sort of like a follow-on question. So after being on the OCBC, the Orange County Business Council, Security Task Force meeting, they had a speaker who talked about how some companies are dealing with ransomware. So they get their ransomware sample, they lose their files. The only way to get it back is if they pay. So what a lot of companies are starting to do is budgeting for ransomware. So, rather than investing in backup.
Right.
And their argument is that this is a cheaper thing to do. Now, I'm just curious, in the Dell's machine learning research, is there anything, maybe some like predictive analytics, which can be used to say if your company gets into the habit of paying ransomware fees, the attackers will keep coming back? Is there anything like that in your machine learning business logic to predict those kinds of things?
Or what might come in the future, like once you've been...
Right, because if I keep paying the ransom fees, they'll keep coming back, right?
Oh, yes.
So
yeah, I think, well, number one, that's a given, right? So if you give in to terrorists, right, they'll just keep demanding more and more next time. But I think that's really where some of the stuff that Robert was talking about with SecureWorks really comes into play, is once an organization is targeted, right? It's got the big, red target sign saying those guys are the ones that we need to keep going after because they'll keep paying, or they're vulnerable for a variety of reasons. That's really where that extra layer of having a partnership with a team of security experts to not only predict, but also predict what these guys might be trying to do, right? Based on what they already know about the organization. I think that's really where the human element starts to come into play, and where it becomes so critical.
this teaches why we should never ever pay ransom fees, no matter how badly you need the data.
Yeah, or just back up your data. And by the way, we have solutions for cloud online backup that I can sell you too.
Just to kind of add to what Dave was talking about, SecureWorks was, since we're a vendor-neutral solution, Dell asked us to actually analyze the Cylance solution for them to make sure it's something they want to work with. We actually looked at it for the first time, analyzed it, did a bunch of check points with it, and we were very impressed with it, and gave Dell the attaboy to go ahead and put the money toward it. So we basically gave our approval to Dell.
Yeah, and I believe that study took about 6 months. They looked at, I think, 24 new startups and technologies out there, and they took thousands of malware, Trojan horses, ransomware variants, CryptoLocker, and they did kind of the same kind of bake-off that I showed you in the 75-city bake-off that we also did. And the results there were even more stark. They actually compared Dell Cylance's solution to 5 products: Symantec, McAfee, Trend Micro, Microsoft, and Sophos. And even there, it caught 99.99% of the attacks that SecureWorks threw at it. The second best was Trend Micro in their study, and they caught 38%. All the way down to products, which I won't name, that actually only caught like 14% of those attacks. So I mean, it's something that I actually see play out in real enterprises, where nowadays when I go into a meeting with the CIO or the CISO, he or she will say, yeah, my antivirus solution doesn't really do that much anymore, right? But, I keep having to pay $1 million a year to renew it.
Okay, I got a big question for you. Ransomware basically is someone's encrypted your drive. You're Dell. You have your own drivers. Why in the name of heaven haven't you put a higher level driver that is untouchable, that if you go to encrypt, you have to go through this higher level driver, which requires multiple reconfirmations before it encrypts? Why are we leaving the drivers to the hard drive open to anybody to access?
No,
This is not a major issue. So why is an industry building in that protection?
Yeah, that's a great question. A lot of times it's because the way that these ransomware works is it looks like it's not doing anything malicious. So the question is, if you want to put that extra layer of confirmation or steps on any encryption solution, that comes at a cost too, right? So most of my customers do encryption, and I actually sell encryption solutions. If you have to put that extra layer of checks or load or performance impact, then that might be a cost. But you know what? You bring up a great point. That's something that
This is really offensive, actually. You just described something that if I was offered $10 option on my laptop to make it ransom proof, I paid $10. And it would cost you X to write that piece of code and you document how many million units you sell a year, this would be minty on your part and would dramatically reduce the vulnerability of your customers, and you can control it.
So how do you know that it's not an encryption solution trying to benignly encrypt the data?
It's back to how you write the code on your driver. You have the ultimate controls interface from the operating system down to the hardware. You control the hardware. You have to put it in wrong, unadulterable, and you have to make it with a separate code that anything goes to that drive, it has to go to there. It alone can control the ability to change data format.
Yeah, and again, if you try to do something like that in practice, the level of performance impact that it hits, a lot of organizations will say no. It comes at too high of a cost if it has to go through that process. Anything that changes anything about my data, if it has to go through that level of scrutiny, it's just going to bog down system performance.
I challenge you to tell me what the performance is with the new level of hard drive access we have now, processor speed. I'm tired of people being told it's going to impact performance when most people don't use more than 10% of their performance on a normal basis. Like PowerPoint, Word, email.
Right.
If you're doing a heavy-duty user, then upgrade the processor, give more RAM, you can deal with that. But every time people tell me, well, they won't accept or degrade, nobody's ever written software and then they benchmark back and forth and said, the impact would be this, and a normal workload is 1%, 2%, 10%. I think most industries will accept a 10% impact if they can get a 2-order of magnitude improvement in their protection there.
Yeah, I mean, that's debatable. But, you know, the bigger problem, though, is let's say we were to do that, and every hardware manufacturer applies that as a standard. Guess what? Encrypting type of ransomware, that's just the flavor of today. They can say, oh, you know what? That's not going to work anymore. We'll find another thing to try to hold companies hostage or steal data, right? So it's a problem where it's again whack-a-mole. It's like if you do all of that, which is almost impossible to get all of the different hardware manufacturers to do, the attackers will find another way, right?
The logic there is kind of specious here. You're talking about an extreme vulnerability. It's the hard drive. It's a known target. If you take away the most critical target, they have to find something else. They're going to have to really work for it, and it may not be able to do as much damage. I mean, to say, well, to find something else is just pushing it. If you've got a target in front of you right now, you don't got to keep shooting at it. You take it down. Then you worry about the next one later, but at least you're not being constantly shot at right now.
Yeah, and you know what? If you look at it, what we're doing here is basically what you just described. It's basically a layer that says anything trying to execute and run and get access to data on my drive will have to go through a series of checks. And in our case, we use machine learning to say, you know what? You cannot touch anything. As a matter of fact, I won't even let you run or detonate or do anything you want to do because I've seen that you do this and that, and you change the registry, and you're trying to hide yourself from the OS. That's basically what we're doing here, right? But it's more general, right? So whether it's ransomware, whether it's off-the-shelf viruses, whether it's a Sony type of attack, which by the way, they actually took this technology and they took the Sony attack to see what would have happened if they had this solution already in place, and sure enough, this actually detected it and quarantined the exact attack that Sony Pictures got hit with 3 years ago.
What's the competition to this machine learning?